Hello everyone, welcome to Chemazon-Complete Chemistry. So in our today's video, we are going to see another question of stereochemistry. In the last video, we had seen part 1, that was the first question that was asked in section B. There was one more question asked from stereochemistry, so this is part 2. So the question was, the Newmann projection given below corresponds to the compound. So these were the options that were given. So here what we have to do is we have to convert the Newmann projection formula that is already given to us. We have to convert it into Wedge dash projection formula. Okay, in the options you can see this is which formula? This is Wedge dash projection formula. So this was asked for 4 marks. In which section? It was asked in section C. Okay, so this is which system? From the options you can see, in all the options you can see there are 2 cyclohexane rings fused like this, right? So there are 2 types of, this is which system? The name of this system is called as, it is called as decalin system. Okay, so there are 2 types. One where at, okay, so at this carbons you can see these are called as bridge carbons. Okay, these are called as bridge carbons, and at these bridge carbons there can be 2 groups. Okay, either mostly they are hydrogens. So let's say one hydrogen is above the plane of the paper like this, and another hydrogen is below the plane of the paper. That is, stereochemistry is opposite. So we can say this is, first one is transdecalin. Okay, or both the hydrogen can be on the same side. Here I am drawing both are below the plane, that is on the dash bond. So this is called as both are on the same side of the paper, or same stereochemistry. Either both are below the plane, or if both the hydrogens are above the plane, that is also same. This is called as cis-decalin. Okay, so we have to identify from the options we can see. We have to draw which structure? We have to draw cis-decalin, because both the hydrogens are on the same side, that is they are below the plane of the paper. Okay, so now let us see how to approach this drawing. First thing what we have to do is, see, if you have started solving this by drawing the planar structure at first, then it is going to be very difficult because it is not easy to visualize like this. So what we have to do is, we have to draw the chair conformation. We have to draw the chair conformation of this cis-decalin. Okay, so how to draw the chair conformation? Let us see. First, I will draw one cyclohexane ring like this. Okay, so here we can see at the terminal position, both the hydrogens are below the plane of the paper. Okay, so that we can draw first. Then, okay, like this. So let me draw again. Okay, so this is what? This is cis-decalin. How can we identify? We can see both the hydrogen are below the plane of the paper, that is on the same side. Now, slowly we can just label one carbon each. So first of all, these dots are what? They are the front carbons. Okay, these are front carbons. Okay, dot represent front carbon, and big circle represent the back carbon, or we can say rear carbon. Okay, so first we are seeing the front carbons. Okay, so let's say this is A. So here this carbon is going to be A. Now hydrogen is above the plane, methyl is below the plane. So we draw like this. Hydrogen is above the plane, methyl is below the plane. Okay, go to the next carbon. This is B. B, there are 2 hydrogens. Okay, B. Then we go further. C, one hydrogen is below the plane. This is C. Now we go to D. D, there are 2 hydrogens. So this is D. Then we come here. It is E. So this is E. Now here how we draw? hydrogen will be, there are two groups like this. Okay, both are hydrogen at E. Okay, and then let me erase this. Okay, here again there will be two groups like this. Now you can see between both the hydrogen which group is present? Methyl. So between both the hydrogens on the right there is methyl and on the left there is hydrogen. So we are seeing which carbon? We are seeing F. Okay, this big circle. This is F. Okay, here this is F. Methyl is on the right and hydrogen is on the left. Okay, so now all the groups are done. Now what we can do? We can number this ring. Okay, we will start numbering from here. 1, 2, 3, 4, 5, 6, 7, 8, 9 and then 10. Okay, this is 8. Okay, so now we can easily draw the planar structure. I can draw here. Okay, let us number this as well. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, now we can draw the groups. So at the second position there is hydrogen which is above the plane like this, and below the plane there is methyl. Then at the fourth position hydrogen is below the plane. Fifth, sixth position there are two hydrogens. Seventh position again hydrogen is below, hydrogen is above the plane. Okay, so on the dash bond means above the plane, right? Sorry, wedge bond means above the plane, and dash bond is like this, which means below the plane. Here we can see there is methyl at the 7th carbon. 8th there are two hydrogen. 9th again there is one hydrogen. This hydrogen in yellow you can see it is below the plane. So this is going to be the final structure. And what is the stereochemistry? You can see both the methyl groups are below the plane of the paper. So which is going to be the correct answer? So here we can see, okay, which is going to be the correct answer? Both the methyls are below the plane at this position. So correct answer is option 1. I hope this answered your question, and I hope you have understood the solution as well. Thank you so much. Please subscribe to our channel and don't forget to press the bell icon. Thank you.